The momentum of this car is equal to its mass multiplied by its velocity. This means that the car's momentum increases when it accelerates, and its momentum increases when its mass increases. The momentum of an object like this car affects what happens in a collision. To describe what happens in collisions, we need to understand Newton's laws of motion. Understand the law of conservation of momentum. When two objects collide, each object exerts a force on the other object. The force of object A on object B is the same size and in the opposite direction to the force of object B on object A. This is Newton's third law. Notice that it does not matter whether one object is big and the other is small, or if both objects are moving in the same direction, or even if only one is moving. There is always a pair of forces equal in size and opposite in direction. Newton's second law of motion tells us that force is equal to the rate of change of momentum. This is the change in momentum, delta P or delta mv, divided by the time taken for the change, delta t. When mass doesn't change, force equals mass multiplied by acceleration. The force acts for time delta t. B touches A for exactly the same time that A touches B, so the equation becomes delta MAVA equals minus delta MBVB. This is the law of conservation of momentum. The change in the momentum of A is exactly the same magnitude but opposite in direction to the change in the momentum of B. The total momentum remains unchanged. This is only true if there are no other forces changing the motion. For example, if A is slowing down due to friction, then momentum is not conserved. Here, two objects collide, stick together, and continue travelling. A has a mass of 350 kilograms and is moving at 2 meters per second. B has a mass of 400 kilograms. It is travelling directly towards A at 1.25 meters per second. So, if we take the direction of A as positive, B has velocity of minus 1.25 meters per second. The total momentum before the collision is the momentum of A plus the momentum of B. This equals 700 minus 500, which equals 200 kilogram meters per second. Because the two cars stick together, their total mass is 350 plus 400, which equals 750 kilograms. And if their velocity after the collision is v, the momentum is 750 kilograms times v. Assuming no external forces act on the object, the momentum before the collision is equal to the momentum after the collision. This is the law of conservation of momentum. So, 200 kilogram meters per second equals 750 kilograms times v. V equals 200 divided by 750, which is 0.27 meters per second. Notice that this speed is positive. If the final answer was negative, it would mean that the cars were moving in the opposite direction. Newton's second law tells us that force is equal to the rate of change of momentum. If the mass is constant, this is the same as saying force equals mass multiplied by acceleration. Newton's third law tells us that forces occur in pairs that are equal in size and opposite in direction. The law of conservation of momentum says that if there is no external force on a system, then momentum is conserved.